Okay, let's get on with Mr. Al-Khalili. And he started the other day saying that this is his quick bio, okay? And Mr. Al-Khalili says that he's a theoretical physicist, okay? And so he's got all these jobs and titles and so on. But we found out very quickly that usually they tell me, okay, I'm reconnected. I'm back, I think. Let me know if you can't see or hear me. Okay. Yeah, Mr. Al-Khalili, it turns out to be a caricature of science and of physics. Why? Because he says the atom is mostly empty space. Empty space is made of particles, so I don't know what he means by empty. I lost track of what empty means in quantum. A particle can be at two places at once. The strong force is a bed spring. You see it up there on the upper right there. It's a bed spring that holds quarks and protons together. We don't know what a bed spring is, where they got that. It's not on the standard model. So I don't know what physical notion they have of the gluon, of this strong force, okay? We have no idea because they just call it the strong force and they go into math and we don't know what the physical part of it is, okay? He says that spirits known as black holes and dark matter, they lurk in the darkness of dark energy. He says the universe was self-created when concept energy spontaneously morphed into the concept mass. So we have concepts turning into concept. We have love into hate or whatever, right? So we still don't know anything about physics using that language. And then he just says that we wouldn't have computers and GPS if it weren't for all the great scientists and physicists we've got out there. Now, that's technology, has absolutely nothing to do with science. We need explanations for science, okay? So, yeah, but it turns out that Al-Khalili moves from there on to something else. He moves on to saying that the Islamic world created all this science for us, that we inherited all this great science from the Arabs. And so one of the two, either we're not doing science, and the Arabs were not doing science at all, and so whatever they did was not scientific, or you know, Al-Khalili is just blowing hot air. That's it, because you know, what is science? That's what we want to try to find out today. Is Al-Khalili doing science? And if he's doing science, he can say, well, you know, it was because he was born in Baghdad, so he's from an Arabic origin. So he glorifies his ancestors, saying, look, these guys created the science we have today, but the question is whether we have science today. And if we don't, then whatever the Arabs did not contribute anything whatsoever to science. Okay, so let's get that straight. Did the Arabs do science? Are we doing science today? And I'm saying that again, this caricature of a physicist, he's probably like Rutherford said, he's doing stamp collecting and not science. That's different. Okay, science is something else, and physics is something else. And so, what does Al-Khalili do? Well, he's we got the BBC, and he's the poster boy for the Islamic science for the BBC, as well as for other types of science. He talks a lot about so-called science out there. Okay, he argues that science is about math and experiments. Is that so? Is that what science is? Math and experiments? Because that's what he's going to say, okay? Between, he says, the 8th century and the 12th century, somewhere in between there, which was the, I guess, the golden age of the Arab empires, etc., the Islamic world that had flourished and expanded, the Arabs developed math. Okay, so they developed math. Did they develop science? That's the issue. They invented many useful artifacts. Okay, that's known as technology. Is that science? They developed medicine and chemistry. Exactly what? I mean, did they understand what they were doing? You know, I mean, they did chemistry, but one thing is when you go to the lab, you pour two liquids together, you do a kaboom or whatever. Say, oh, I never mix those two chemicals again because they create a big kaboom. Did you understand what happened? No. All you know is that when you mix red with blue liquid, it explodes. That's it. Does that mean you understood the mechanism? No, it just means you described it. Red and blue don't mix, so don't do that. That's all. That's a description. So that's different than saying that you understood, which is what we're talking about science here, okay? They originated much of the language used today in science. Well, if what we do today is not science, then maybe the language that they bequeathed to us was not scientific, okay? Maybe we're misled into believing that we received scientific words from the Arab world, okay? Therefore, we should give credit to the Arabs for discovering resurrecting science, okay? Because supposedly the Greeks, they went away and nobody did science for about 1,000 years until the Arabs came around and they started translating some of the Greek books, okay? And from there, they used that as a stepping stone to develop, again, math, technology, and medicine, chemistry, and so on, but not the understanding part. What they developed was the practical part, the hands-on, the technology. And the question is whether that qualifies as science. Did they understand how this universe works? Did they understand how a magnet attracts another one? Did they understand what gravity is? And I think the answer to all those questions is no. And we're going to get to light especially, because that's one of the ones that they did tackle, okay? And that was inherited later on by the West. Okay, so here Mr. Al-Khalili really comes across more as a born-again mathematician, born-again Christian instead of a born-again Muslim, right? He's really coming across as trying to sell you something, okay? Because he's trying to, at all costs, trying to tell you, look, the Islamic world invented everything, and we inherited a lot of stuff from them, so give them credit. Well, give them credit for what? What did these guys really bequeath to us? Did they bequeath technology? Yes. Did they bequeath mathematics, especially algebra? Yes. The decimal point, etc.? Yeah. Is that science? Is that physics? That's going to be the issue, okay? And yeah, you can see that he says he doesn't believe in God or angels or spirits, but he believes in space-time, black holes, dark matter, and other nonsense. And so the question is whether this gentleman is a scientist or is he just, again, blowing hot air. Okay, moving on here to Mr. Al-Khalili. He puts on his turban and he's going to say the scientific method is, I believe, the single most important idea the human race has ever come up with. Have they come up with it? I mean, I think the scientific method was born in the year 2000, 1998 to be more exact. Before then, there was no scientific method. All we had was math and experiment, no understanding. In fact, what I've been talking about the last couple of weeks is that all these people say, we don't understand quantum mechanics. We don't understand it. Well, if you don't understand it, then don't tell me that you're doing science. Because science is about understanding. If they don't understand their own theories, as Feynman admitted, what kind of science is that? What kind of theory is one that you don't understand, that you cannot explain? So yeah, I don't know about the scientific method that these people use, and that's what we're going to look at. There is no other strategy that tells us how to find out how the universe works. Well, the word how can mean description or explanation. Is he talking about describing something mathematically, for example? Or is he talking about explaining the causes and mechanisms? What does that word how mean? Okay. Of course, there's also delivered technology that has transformed our lives. Irrelevant, because we don't care about technology. We're interested in understanding how this universe works. We want to know or understand, right, why the Earth doesn't fly out of the solar system. That's what we want to understand. Okay, that's science. And not building a gadget out there in the lab, making money and saying, oh, I'm a scientist. No, you're a technologist. You're not a scientist, because we had, Mr. Thomas Alva Edison. He developed the filament over several months of work. He tried one thing after another until he got it right. Did he understand electricity? Did he understand the causes of electricity? No, he didn't need to, not to develop the filament. So again, technology is one thing, science is something else. And this guy is talking about giving a lot of credit to the Arabs, saying, look, they developed all this technology. I don't deny that. But what's that got to do with science? Okay. And so he says the language of science, and that the Islamic world tried to make the Arab language, the Arabic, try to make it uniform so that the person in Cordoba in Spain, and which was an Arab city at the time, right, could have the same meaning as the guy in Baghdad, which was good. I thought that was excellent from the Arabs, right? Says the language of modern science still has many references to Arabic roots. Okay, take scientific terms such as algebra, algorithm, alkali. I don't know. Are those words of science? These are the very heart of what science does. Is it? I mean, we don't use algebra in science. What is this algebra stuff? I thought that was math. Algebra can be used to describe something. It cannot be used to explain. And this is where we're going to have run into problems with all of what Al-Khalili says. There will be no modern mathematics or physics without algebra. Mathematics, I grant it. Physics, something else. Physics, again, I don't need any algebra to find out how a magnet attracts another one from a distance, or why the pencil fell to the ground. If I want to explain that, I have no use for algebra. So as far as physics is concerned, the Arabs wasted their time. Now, did they develop math? Yeah, sure. No problem there. What's it got to do with science? What's it got to do with physics? Okay? That's why we need to define what science and physics is before we can make statements of this nature, okay? And it would have been great if he would have defined what science is, and he does more or less give you an idea that science is essentially experiment, observation, and math. That's it. That's his notion. That's what he learned at the monastery and what he repeats today, okay? That's where the problem is. And then they have irrational explanations, meaning they don't have a theory that they understand, but he says he's doing science. So I got a problem with all that. And he says we wouldn't have computers without algorithms and no chemistry without alkalis. Well, I don't know. Whether we would have chemistry without alkalis, yeah. Chemistry, the practical part, not the understanding part. Understanding is something else. Chemistry, if you look at it, you need to know what the the elements are, and you need to know what they look like. Only when you know what they look like, you can see how they physically interact. And right now, they don't have an idea what an atom looks like. In fact, what was it last time around? We said that Bohr and Heisenberg, the Copenhagen interpretation, very clearly states you're not supposed to visualize the atom. You'll never make it. You cannot visualize it. It's impossible. And they railed against Feynman because Feynman said, well, look, let me show you a picture, and also Murray Gell-Mann, he said the same thing, it's got these three little quarks in there. Now they said you can't picture the atom, period. You cannot imagine it. And so, that's chemistry. And so to say, well, we have all these elements on the table and this one's over here and that one's over there, that's stamp collecting. That's just naming stuff. You still don't understand what the structure of an atom is, and therefore you cannot tell me how they interact and how they blend or how they form molecules, okay? Unless you forget that orbitals are orbitals and you think of them as balloons. Then yes, then you can explain, okay? Because you can have merger of balloons. You cannot have merger of concepts called orbitals. Okay, so Al-Khalili continues here and he says, while 6th century Indian mathematicians invented numbers 0 through 9, Arabs invented the decimal point. Good for them. Caliphs, like most successful emperors, they understood that political power and scientific know-how go hand in hand. Yeah, okay. But again, not scientific know-how. It's technological know-how. He's confusing science with technology because a caliph, or, I don't know, Suleiman the Magnificent, he didn't need to know why the Earth doesn't fly out of the solar system. He didn't need to understand really why a magnet attracts another. What he wanted to understand, if possible, is how a cannon shot a ball to the fort over there. That he needed to make sure he understood or that he had control over. So again, science is not technology, and this is what Al-Khalili is confusing here. Medical technology could save lives. Yeah, military technology could win wars. Yeah, mathematics could deal with the increasing complexity of the finances of the state. None of that has anything to do with science. Made Arab language uniform to understand the same thing throughout the empire. That was good. Again, language is important. It would have been great if they would have defined their terms, which the Arabs did not do, which today they still haven't done. So, it would have been great if these people would have defined the terms. That would have shown that they understood, that they really had a mastery of the language needed to do science, to explain mechanisms. The Arabs never did that. They never knew what an object is. They never defined the word exist. Okay? But I like this comment by Al-Khalili, like all great science, it's blindingly obvious after it has been discovered. I think he was referring to the rope. Okay, once we discover the rope, it's blindingly obvious. Okay, we can explain light, we can explain the workings of the atom, we can explain gravity. Okay, so I guess that's what he was referring to when he says it's blindingly obvious. Yeah, once they discover the rope, makes them think. At least it gives them an alternative instead of particles, which is what we have today. All we have today is particles. Okay, Al-Khalili continues here, and he says, every now and then an idea takes form that changes everything. Yeah, that's the rope model. Okay, it revolutionizes the way we see and understand the world around us. Absolutely. Okay, all you got to do is get in touch with the rope model, and you'll see a different universe. Whether you believe in that or not, it's your personal opinion. Here we're saying that you're going to see a different universe, no doubt about it. Such an idea took form in the medieval Islamic world. The idea that everything from the stars above to the workings of our own bodies is not arbitrary or whimsical, but subject to certain systematic rules. Okay, I don't know what rules he's referring to. I guess God ordained certain rules. Are we talking about constants, the velocity of light, the mass of the hydrogen atom? What are we talking about here? What's more, we human can work out what those rules might be. Okay, how do we get there? And then we can refine and test our theories. Test a theory? What do you mean you test a theory? How do you test an explanation? I give you a mechanism, okay, and all you got to do is understand it. You don't test it. You want to test it at your home and say, well, I don't believe in this mechanism. Okay, you don't believe in the mechanism. For example, let me give you a for instance. I give you an explanation of why the window broke. The window broke because Johnny threw a rock through it. Okay, you understand it. Now I say, well, the window broke because he threw a sponge ball. You say, well, I don't know about that. He threw a sponge ball at the window. I don't think that would break the window. And so now you go home, you test it, and you throw your sponge against the window and say, well, it didn't break it, so I don't believe in that theory. Okay, and you come back to me and say, hey, yeah, I don't believe in your theory. Okay, I don't give a damn if you believe in my theory. I'm saying he threw a sponge ball and broke the window with a sponge ball. Says, yeah, but I tested it at my lab, and I threw the sponge ball, and it bounced back, and I threw it 1,000,000 times, it never broke the window. I still believe in the sponge ball. That means that you're not going to convince me if I insist on believing something. No matter how much evidence, how many tests, how much proof you present, I'm not going to believe you. I don't want to believe you, and I don't want to believe you. And what are you going to do about it? So this is the issue. The issue is that whether you run a test, an experiment, and come back and say you're wrong, that's your opinion. Okay, people don't understand that. That's got nothing to do with science. Running a test, an experiment, only convinces you of something. And some people will say, hey, the rose that I found in my garden, that's proof of God. What do you mean it's proof of God? Yeah, because only God could have made something so perfect with a bee buzzing around at that symbiotic relationship. I don't believe in your God. Yeah, but I believe in God. And I can show you it's not true. Look, and I can say whatever I want. The guy's going to continue believing in God. He's going to have that God theory that God made the rose. And you're not going to change that with an experiment. Even if you stick his nose into the rose, he will not believe you. So experiment is only used to persuade, convince, convert, and recruit. Experiments have nothing to do with science. You can run whatever experiment you want to convince yourself to reach your own conclusion. At the conference, all we do is explain the mechanism so that you understand what mechanism is proposed for gravity, for magnetism, for light, etc., for electricity. So experiment has nothing to do with science. Experiment attacks the religious part of you. It has to do with convincing and persuading you, or you convincing yourself. You run an experiment to convince yourself to reach your own conclusion. That's got to do with belief, not with the mechanism. Okay, so that's not always clear to people because people are very stuck on this issue that experiments prove. No, it proved to you. Didn't prove to the guy who continues to believe in God that there is a God and that God made everything. He still believes in God. You might come whatever proof and experiment you want. You're not going to convince him because we're talking about two different things. One thing is the mechanism, objective, and the other one is belief. That's what experiment tackles. Okay, anyways, and then we refine and test our theories. No, we don't. Through observation and experiment. No, you can gawk all you want. You can do all the experiments you want. That's only to convince yourself. In other words, it's the idea we now call the scientific method. Absolutely not. The scientific method has to do with explaining something objectively, rationally to someone else. That's where science stops. What continues from then on is belief. Okay? Okay, so here... if I can get this thing up there. Here we have some balls. You're observing. You ran the experiment. Okay? And they're vibrating. Now you can see none of these balls are touching each other. Do we have pressure in there somewhere? I mean, you have the flat earthers especially and some of these other people who talk about pressure. And they say, you know, pressure causes this and pressure causes that. Well, you can't do pressure with particles if they're all discrete. What compels one particle to hit another particle, to hit another particle, and so on? Are we talking about billiard ball universe? What starts the outer particle from coming, you know, what starts it to come in and push the first particle inwards in this ether world, in this particle world? See, none of those particles are touching each other. They're vibrating, I don't know, because of magic. And you say, well, you know, there's pressure. Well, where's the pressure? None of them are touching each other. So yeah, one of the big problems with the particle model and observation and experiment is that first we can't see all these invisible things that are out there, you know, all these so-called particles, the ether and so on. We can't see all that stuff. And so you can't rely on experiments and observation because we don't see everything that we should be seeing. Now let's make it visible. Here we make it visible. And we see, yeah, now I can see why those particles are vibrating and why they don't need pressure from the outside because they're being pulled by something that interconnects them. Okay? So now we can explain some things. With the loose particles, with the discrete particles vibrating, we can't explain everything. There's a lot of stuff we cannot explain with that. And especially we cannot explain gravity because if gravity is a pull force, how do you pull with particles? And obviously what they've done is use it as pressure. And again, even in the Casimir type mechanisms where you remove the stuff between two objects, what you're relying is on the pressure that pushes them from the outside. What is that pressure? Particles. How, if all these discrete particles are loose there, how does one influence the other particle? I mean, are we talking about a sandbox where all the particles are just touching each other? And if we have a sandbox, how does that sandbox cause pressure? So again, you got to explain whether you got a sandbox or you got loose particles. If you have loose particles, you can't explain anything. So you more or less have to have this sandbox thing where all these particles are tied to each other. Okay? But it turns out that the sandbox fails as well because there's space between two grains of sand, because otherwise you wouldn't have two grains of sand. You would have a single block of sand. So if you have grains of sand, each one is contoured by space. How does one sand touch another sand if they have separation. And unless they blend and become one object, you don't have touch. You have separation. And if they have separation, how does one sand grain push on another one if both are separated by space? Or there's space between them, there's distance between them. Very, very small distance, it doesn't matter, but there's distance. Otherwise, they wouldn't be two separate grains of sand. How simple it is. So no, you can't produce pressure with sand, okay? And that's different than what we see inside a gas chamber, okay? You have all these gas molecules moving around. They cause pressure. Why? Because they're bouncing. They're hitting walls, and it's that motion which causes pressure. And the higher you take the heat, the higher the pressure. Now we can understand that. That's different than saying we have a sandbox. And you're standing there and say, I'm waiting for the sand to push the ball. No, it's never going to push the ball. Believe me, you can wait all your life. The sand on the beach is not going to move the ball. Okay. Yeah. No particles. Particles dead. Particle hypothesis never had a chance, and that's all we've done in the last 10,000 years. Just particles. Even waves are particles. Okay, Al-Khalili continues. Arabs translated Greek books, made advances in medicine and engineering and military, no doubt there. To be an administrator, assess taxes, etc., needed to know mathematics, no doubt there either. None of that has anything to do with science or physics. To build monumental buildings required knowledge in architecture and mathematical skills. Yeah, science. What is science? Numerical record keeping and measurements. Why do they have to take it back to measurement? What's measurement got to do with science? I measure a chair. Measures 1 meter by 1 meter by 1 meter, or whatever. That's science. I measured, and it's science. I've got a number, I've got an equation, and that's science. Just a description of a chair. Or I clock. I don't know, a boy running, a man running. He runs 100 meters in 10 seconds. That's science. I clocked him. I know how fast he ran. That's science. Okay. To understand the world, you have to build devices to measure it. No, you don't. To understand the world, you have to visualize the mechanism. Then you'll understand the world, especially the invisible stuff, the intangible, invisible stuff. Light, gravity, magnetism, electricity, all that stuff you need to visualize. You can't run an experiment or measure anything to determine the physical nature. That's the issue. Measurement can make sense of the world around us. Yeah, they've been measuring for the last 10,000 years, at least, I'd say. The Arabs measured, the Greeks measured, Galileo measured, everybody measured. And today we have irrational explanations. So I think that tells you something about the scientific method that they're using. This measurement, observation, experiment, and calculation has led us to ridiculous conclusions. First, they admit that they don't understand their theories. Then they give you irrational explanations. They bring black holes and dark matter and other nonsense, Big Bang, into science. What's that got to do with physics, with understanding how the universe works? I need to know why the Earth doesn't fly out of the solar system. What are you going to say? That time is warped, and that's what the skin of Earth comes up against, warped time? What kind of explanation is that? So no, apparently their scientific method, whatever they think is scientific, is not working, hasn't worked. Okay? So we got a problem with the scientific method, especially the one that Al-Khalili is trying to use here, or shove down your throat, which is the one they shoved down his throat at the monastery where he studied. Okay, we have this gentleman. His name was Alhazen. Alhazen. He's got different names translated into our world. And they invented algebra that allowed them to calculate the radius of the Earth. Big thing. Okay, so we know the radius of the Earth. So again, if you measure a chair, you're a scientist. What's this got to do with science? Measuring the Earth. And knowing how big the Earth is, so what? These guys wanted to do that because they wanted to know how much of the world their empire covered. Was it 30%, 20%? How much of the world do I have? Am I the owner of? That's what they wanted to know. That's got nothing to do with science. Got to do with politics, if anything. Accuracy to less than 1% today is value. Who cares? So they were quite accurate. Even and today we're a little more accurate. What does that tell us? You know, you had this fellow, Michelson. He spent his entire life just measuring the speed of light. He got it ever more accurate. Was he a scientist? So you know this. You know, in rational science we say it's fast. Now, how accurate is that? Light is very fast. That's good enough for us. Okay. We don't need to know the exact value of the speed of light. We need to know what light is and why it behaves the way it does because of its architecture, its physical architecture out there in the secret world of Mother Nature's. Okay. Callis pushed the idea that abstract geometrical rules governing idealized shapes like perfect circles and triangles can help us comprehend the real world. If that's true, we should be geniuses today. And that's not true because today nobody understands the universe. Nobody can tell you how gravity works, how magnetism works, how light works. With mathematics, humanity can embrace the universe. I don't think so. Mathematics has helped us. If anything, it took us on the wrong path because we went on a tangent doing experiments in math and observation, and today we have irrational explanation. So what has math helped us? I mean, I don't know. You tell me. If anything, it took us out of the path of physics. Okay? It became very abstract. Okay, in this story of the birth of the scientific method, supposedly in the Arab lands, right, the Islamic scholar's ability to master sophisticated mathematics is the first crucial ingredient. Yeah, if that's what you think science is. The second crucial ingredient is the use of experiments in science. Again, math, experiments and math. Okay? Without experiments, theory remains meaningless. Theory remains meaningless. I can give you an explanation of how I pulled the box. I had a rope tied around a pulley and I pulled on the rope and that's the box went up. I didn't need any experiment. I didn't need any math to explain that mechanism. I didn't need any experiment to tell you how the window broke. I just said, look, I think, this is my theory. I think Joey, the guy next door, he hates you and he came with a crowbar and just banged your window and broke it. That's, I think, my theory. Why do I need any math or any experiment? Do I need to run an experiment? No, you just understand my theory. You believe whatever you want. You want to run an experiment, go ahead. Okay, maybe you think it was a baseball. I don't know. So no, we don't need experiments or math, but this is the notion that we inherited from the Arabs and that these people still have today in all these monasteries they call colleges and universities. And that's what they pass on to the next generation. Okay, here's Al-Khalili again, moving on, and he says Islamic scholars use experimental observation to classify the stuff the world is made of. Yeah, they use experiments, but they did not understand. They did their little magic there in the labs, mixing stuff, you know, and they discovered that, for example, spirits were flammable, metals were shiny and malleable, salts dissolved in water. Yeah, they did that by trial and error. You know, like again, Edison, he did stuff by trial and error. He didn't understand squat. It didn't matter. But he came up with the filament. He made money. What's that got to do with science? What did he understand? What can he teach me? Okay. And so they grouped substances on the basis of experimental observations, not philosophical musings. In other words, they had this notion that we have today. That's what Al-Khalili was talking about, that we have the periodic table. Well, they had a periodic table consisting of 6 groups of, salts and spirits and so on, metals. Okay, that's called stamp collecting, as Mr. Rutherford would say. What's that got to do with science? Stamp collecting is not physics, it's not science. All they did was name stuff. Okay, so they know how to name. They could have named it XYZ and put it in different groupings. What does that have to do with understanding, with explaining, with having mechanisms? Okay. Okay, here he tries to shoot down Aristotle, Al-Khalili. He says, until the 9th and 10th centuries, ideas about science and how the natural world works were dominated by the Greek philosopher Aristotle. He believed that mathematics, I like this part, was concentrated only was concerned only with an abstract world of perfect forms of idealized shapes like circles, squares, and triangles. It had no power, this is the part I like, it had no power to explain what we observe in the world around us. Absolutely correct. It has no power whatsoever. But look, he says, uses the word explain. But when he comes back and criticizes, he's going to change that word. He says the story of how humanity shook off this idea and began to see that mathematics is actually an incredibly powerful way of describing. I thought we were talking about explanations. How did we suddenly morph into describe? The world around us is long and complicated, but to me, Islamic scientists played a crucial role. And yeah, we got a problem because he goes back and forth between describing and explaining. And so I don't know what he's talking about. Is he talking about description or explanation? Does he know the difference? Okay. And so he says that Alhazen, he studied light. He did experiments on light. He observed light, again. He wrote a book of optics. What really marks this book out as science, according to Al-Khalili, right, is that Alhazen carefully justifies his theories with detailed experiments that others can repeat and verify. Remember, repeatability, verifiability, that's got to do with belief or with verifying that the other guy did this experiment. So I did the experiment as well. I let go of the ball and falls to the floor. Okay, so we both did the experiment. He did it in Cordoba, I did it in Baghdad. Okay, so I repeated the experiment. And do I know because of that, can I explain why the ball fell to the floor? Just because I repeated the experiment and verified that his description is correct, and maybe I even know the acceleration of gravity because I measure and say, yeah, he's right, it's 9.8 meters per second squared. Does that give me any idea of why the ball fell to the floor? Which is what we don't have today. We don't have mechanisms today coming out of mathematical physics because they follow this line of thinking. They think this is science, the scientific method. He starts from first principles to find out how light travels. Oh, okay, he's going to tell us how light travels. Oh, I'm interested now, okay. It defined our modern understanding of light and vision. Okay, so what did good old Alhazen, he's got several names translated in different ways. Alhazen or Ibn Haytham, Alhazen. I use Alhazen usually. And this is it. Here we see it. This is what he said. This is what Alhazen discovered. Alhazen asks, could light and vision be explained by mathematics? How do you explain by mathematics? He wanted a mathematical explanation. Mathematical explanation, that's an oxymoron. You can't explain with mathematics. You can only describe. And he's using the word explanation. So obviously, Al-Khalili has no idea what the difference between a description and an explanation is. And he says, light, he said, referring to Alhazen, does travel in straight lines, but instead of coming out of the eye, which is what the Greeks believed, right, that light came out of the eyes and went to the object, these rays travel into it. Is that true? Do rays, whatever rays are, travel to your eyes? Like, I got to wait for the ray to come from the sun to reach my eye? Is that what's happening? Some ray, whatever it is, I don't know, some spears? Is that what a ray is? A spear that just is shooting, Apollo is shooting spears into my eyes? Is that what light is? It is the beginning of mathematizing physics, yeah, which sounds a lot like this is the origin of mathematical physics. There, I think he's right. I think the Arabs originated mathematical physics, meaning they weren't doing physics, they were doing religion, okay? They were doing description, they're not doing explanation. Alhazen took principle of geometry governing straight lines and applied them to the real world. He then designed experiments to test whether the real world measured up to his mathematics. Maybe to his mathematics, not to the real world. One thing is that the equation describes what he did perfectly well. Another one is whether you got the right mechanism. whether you got the right visualization of what's going on in that invisible, intangible world of Mother Nature's. Okay. Okay, so the first thing we have to note is that Al-Khalili has no idea what the difference is between an explanation and a description. Description, all the above. Mathematics, all those equations, those are all descriptions. None of them is an explanation. So if Alhazen was trying to look for a mathematical, equational explanation, he was out of his mind. He didn't know what he was doing. And mathematician, an individual who doesn't understand the difference between a description and an explanation. Description is what you see above. Explanation is what you see on the bottom. Mechanism. How did the window break? How did the pulley come up? How did the ball, or what caused the ball to roll down the inclined plane? How did the two eggs do their seesaw? Why did one come up? Why did one come down? So we're talking about mechanisms, objective mechanisms that you can illustrate, someone can see and say, oh yeah, I understand the mechanism. Now, whether you believe that the window broke because a stone was thrown there, maybe some other way, maybe it was a tornado or whatever, you know, fine. Everybody's got his own theory. But the issue here is that by looking at the little film strip there, you understand what I'm proposing for how the window broke, how the box came up. You just look and say, okay, I understand what you're proposing. Whether you believe it or not, that's a separate issue. You want to run a test? You want to observe? Go ahead. Prove it to yourself. Okay, prove it to others that believe like you. That's all you can do. But you can't undo my mechanism, the mechanism I'm proposing. All you're doing is saying, I don't believe in your mechanism, Bill. Okay, you don't believe in my mechanism. Fine, I have no problem with that. I can live with that. You don't believe in my mechanism. I'm going to cry all the way to the to hell. Okay, so did Alhazen hit it on the nose? Well, I'm saying I don't think he hit it on the nose. Alhazen thought that it was particles coming out of the eye, or you could, that was the Greek version. His version was that those particles came into the eye. Fine, same thing. Same with the waves there. What are waves? Well, they're a bunch of vectors. That's all that it is. That's mathematical vectors. That's not a physical object that you see under waves. What they think it is a bunch of particles moving up and down. And again, you cannot explain this with particles. Okay, but they come into the eye. What does the rope model propose? Well, that two atoms are interconnected, and you have light is simply the torsion of the rope that interconnects them. So Alhazen may have the wrong idea anyways. He did not prove that particles come into your eye from the object, from the source. Maybe nothing is coming into your eye. Maybe you don't have a little ball that's hitting your eye. So again, Tanamura, Alhazen, there are other mechanisms. All you have to do is compare them, reach your own conclusion once you understand, other mechanisms. Okay, so let's summarize here. Okay, real quick. Science and the scientific method start in the 8th to 11th century Islamic world, according to Al-Khalili. Okay, Islamic scholars revised the Greeks. Okay, Arab Industrial Revolution, medieval technology developed. There was this expansion of the Muslim world, of the Islamic world. Okay, got all the way to Spain. In fact, Charles Martel, he was the guy who stopped them. Okay, general, French general, those days. Okay, long time ago. Math evolves, yeah. They developed algebra, they invented decimals. Manufacturing, no doubt about it, expanded. Technology is not science. So the fact that math and technology evolved, so what? What's that got to do with science? If anything, again, they misled us. They took us on the wrong path because we said, oh, the Arabs know. We translated their books into Latin, into Western languages later on. And all we did was just copy the descriptions. We copied their math. We copied their technology. We couldn't copy their science because the Arabs never did science. Neither did the Greeks. Neither did anyone all the way to the 20th century. No one did science because we don't have an explanation for the invisible phenomena that Mother Nature runs out there. We don't have explanation, rational explanations for why the Earth doesn't fly out of the solar system, how a magnet attracts another. For simple things, these things should be kindergarten stuff. I mean, how difficult it is. You've got the sun and the earth, rock and a ball of fire. All you got to do is explain gravity. Now, how difficult can that be? Do you need any math? Do you need to run an experiment? No, you need to explain it. You want to run an experiment? Go ahead. Let go of the ball. Here's the ball. Okay, and let go of it. Comes down. Okay, that's the only experiment you ever need for gravity. Now explain it. Why does it come down? Why does it hit the ceiling? That's what you get explained. Math is just a description. It's not science. Science is explanations of mechanisms. Okay, misconceptions regarding light, despite observations, despite experiments. Okay. Calculations, measurement, and he ended up, Alhazen at least, he ended up with the wrong notion of how light works, and today we have the same erroneous notion that Alhazen put forth. And again, the reason it's irrational is that you cannot explain with waves how a particle goes up and down. And with particles, you cannot explain the wave nature of light. So both of them get knocked out, both the wave and the particle, because you cannot explain the feature of the other. So Alhazen had it wrong. It's not particles coming into the eye, and quantum has it wrong. Classical mechanics has it wrong. All of them have it wrong because you cannot explain it with particles. You cannot explain light with ether, okay, which is a bunch of particles. Okay, here's homework for you, okay? Finishing up here. Here's the homework, food for thought, okay, and here it is. Is science description? Is science measurement? Is science equations? Science irrational mechanisms, such as particle can be at two places at once? Is science about persuading, converting, convincing, recruiting? Is that what science is about? Is that why we present evidence? Is that why we try to prove? Is that why we say observe? Because I observed means I proved, and you better believe me because I proved it, I observed it. Is that language designed to persuade you to change your mind? Is that what it's all about? And if explanation of a here's the punchline, right? If explanation of a physical mechanism is philosophy, as dismissed today by mathematical physics, why do mathematical physicists like Al-Khalili even bother to give physical interpretations to their measurements and calculations? I mean, if they stay within the realm of mathematics, no problem. But it's when they cross over into physics and say, oh, I can tell you how the physical universe works because of my equations. I can interpret them. I have this magic crystal ball. I can tell you what those equations mean in physical terms. And then immediately after that, they say, we don't understand it. Hold it. You came to explain, you're saying it's philosophy, and then you even try to give me your philosophy saying how this universe works. And you say you've proven it with equations, with experiments, with observation, and now you tell me you don't understand it? So we have a problem because why do these people cross over into physics? If they want to do math, go ahead and stay at the asylum, math asylum, stay and do calculations all day long. It's when they cross over into physics. And they have to cross over into physics because otherwise their mathematics would be completely irrelevant, which it is for the purposes of science. We'll see you next time, same station. We'll see you then.